Okay, so we talked about the acidic and basic properties of ions yesterday. So now we're going to talk about the acidic and basic properties of salts. Remember that salts are simply a cation and an anion together, or an ionic compound. So you may have always thought of salt as like table salt, but there's all sorts of different kinds of salt. So table salt is NaCl, so is rock salt. But you might see, if you went to the store, you might have saw something that's labeled ice melt. That's also a salt, but it's just not NaCl. NaCl is kind of a cheap salt. So let's start with NaCl. Anybody got an instinct? Acidic, basic, or neutral?
Neutral.
It is neutral. That is correct. You guys are already well on your way to understanding this. Remember, the first step you would do would be to split it up into an anion and a cation. The anion you would put with OH. Cation you would put with H+, and then classify it. So this is a strong acid. So this is the conjugate base of a strong acid. Therefore, it is neutral. This is a strong base. So this is the conjugate acid of a strong base. Therefore, it is neutral. So when you have a neutral cation and a neutral anion, the salt is considered neutral. So we can make a list. Any cation from group 1 and 2 or any anion that comes from a strong acid are going to be considered neutral. Now, let's talk about one that you also might be familiar with. Anybody got an instinct? Acidic, basic, or neutral? It is basic. Does anybody know what that substance is called? There's lots of different salts in the ocean. That's a common misconception that the ocean is made of one type of salt. There's quite a few types of salts in the ocean. This is called sodium bicarbonate. This is the main component in baking soda. You know, this guy, sodium, of course, is a group 1 metal. So if you had to explain why, you could say it is the cation of a group 1 metal. It is the conjugate acid of a strong base. Therefore, it is neutral. Let's turn him into an acid. We'll turn him into an acid from an ion. Obviously, this is carbonic acid, which is a weak acid. This is the conjugate base of a weak acid. Therefore, it is basic. So you have a neutral cation and a basic anion. This salt is basic. So sodium bicarbonate can be used to neutralize acids. So if you're in a pinch, if you had heartburn or acid reflux, you could drink a solution of sodium bicarbonate, and that would neutralize the acid in your stomach. So sodium bicarbonate was a long time the main component of Tums, But then before they had all these fancy acid reflux medications, like you go into any diner or restaurant and they would have a rack of Tums because people were just eating Tums left and right. So that was just a common thing to see at any restaurant before they came out with, you know, any of the acid reflux medications. And then they realized that people were ingesting way too much sodium. So now they make it with like calcium bicarbonate. So you might see on the Tums or any of the other equivalent to Tums, it might say good source of calcium because they replace sodium bicarbonate with calcium bicarbonate. Exactly, we need calcium in our system. Acidic, basic, or neutral? You've got aluminum, which is not a group 1 or 2 metal, so that has to be acidic. And then you have nitrate, which is the conjugate base of a strong acid, so it's neutral. So again, how we go about this is we pluck the ions apart. So take the cation, add OH, and decide if it's strong. Take the anion, add H plus, and decide if it's strong. So if it's strong, it is a neutral cation. If it's weak, it is an acidic cation. If the acid in this case is strong, it is a neutral anion. If it is weak, then it's a basic anion. Remember, the level of acidity comes from the ability to donate protons. The level of basicity for the anion has to do with its ability to accept protons. I'm going to show you one thing, and then I'm going to do the caveat of we're not going to go into this too much because it's not on the AP exam. That doesn't mean that you're not going to have to know it at some point in time. What if you had, so remember the cations are going to be acidic unless they are group 1 or group 2 metal cations. So let's just come up with a situation that might be confusing. And this is the one we're not going to quite go over. Can anybody name that compound? It is ammonium hypochlorite. Let's go over the chlorate series again. So remember, Cl minus is chloride. ClO4 minus has the most amount of oxygens on it, so it is perchlorate. Chlorate is ClO3. The ATE versions of polyatomic ions are either going to have 3 or 4 oxygens on them. So the guys on the outside of the nonmetals are going to have 3 oxygens. The guys on the inside of the nonmetals are going to have 4 oxygens. This is called chlorate. The ATE version is the most common. So knowing the ATE versions of your polyatomic ions is crucial. One less is chlorite. Remember, I did post a bunch of naming reviews. So if you don't remember your naming, you might want to go back through and watch those and recognize those before the AP exam. So that's my series with chlorine. Those are the possible polyatomic ions with chlorine. The most has a per and an 8, the ATE version, the ITE version, and then the least has hypo and ite. So let's go to ammonium. Is that acidic, basic, or neutral? Acidic, right? Because he has an H plus to donate. How about hypochlorite, acidic, basic, or neutral? So now, if somebody asked you, is this salt acidic, basic, or neutral? You'd be like, seems like it should be neutral, right? Because you got a little bit of acid in the front, a little bit of base in the back. But what you would have to do is you would have to find some Kas. If you look at NH4, its Ka is 5.64 times 10 to the minus 10, like such, meaning that NH4 is a very weak acid. So actually, in this case, ClO wins out. That being said, do not expect to see any salts that have an acidic cation and a basic anion. For our purposes here, one of them will be neutral, okay? So we're not going to do the battle of the Ka, Kb at this level. Okay, there you go. Okay, let's practice classifying a few more. Acidic, basic, or neutral? Calcium hydroxide is a strong base. Hydrobromic acid is a strong acid. That's neutral. Acidic, basic, or neutral? Don't let me trick you. That's a strong acid. Let's see. Acidic, basic, or neutral? This one, that list is not complete. So let's make sure we understand what our 6 strong acids are and are potentially our 7th. So not all of them are up there. Oh, and the last one, which is not, is a strong acid, but it doesn't play by the same rules. So this is the anion of a strong acid, so it's neutral. And what about zinc? Acidic. So this would be classified as an acidic salt. Meaning that when it put into solution, it will grab some OH minuses and leave behind H pluses, and it will lower the pH. What do you classify this as? That is a weak base. Review one more time. If it starts with H plus, we're going to call it an acid. If it ends with OH minus, we're going to call it a base. if it is an ionic compound, we're going to call it a salt. So this guy here is an alkali metal salt, or the conjugate acid of a strong base. So this guy's neutral. This guy here is the conjugate base of a weak acid. Therefore, we're going to call this a basic salt. So a question on the AP exam like this might look like, what would be the pH of a 0.1 molar solution of sodium phosphate? And they would give you examples of pHs. One would be exactly 7, which is what most people would pick if they had not learned about the acidic basic properties of salts. Wouldn't you assume that salts were neutral because they're not acids and they're not bases? But that's not the case. So just keep in mind, if you see a question that they're asking you for a general possibility of the pH of a solution with a salt, you have to look and see what kind of salt it is based on its anion and its cation.